Okay, hey everyone, today I'll be doing the term 1 week 6 math CA quiz. So I'm going to start with question 1. Given f of x is equal to all of this, what whole number is equal to f prime of 2? Now, I'm going to start off with the calculator method, so follow with me on the calculator. If you have a calculator with an integral, if you don't, I will explain the method you do by hand. So we're going to press shift, okay, and then we're going to press the integral button. The integral button on your calculator looks something like this. Okay, it has two boxes here, and then a big box here with bolded. Okay, press shift and press this button, you're gonna get the derivative. You're gonna, on your screen, you're gonna see something like this: d by dx, bracket square bracket, then this line here, x equals box. Okay, so now what we're gonna do is we're gonna write 18x squared over 1 plus x in our first box. We're gonna write it in here. So 18x squared over 1 plus x. Okay, now we're gonna move over to this side here. We're gonna move over to this one, this little box here. We're gonna write x equals 2, or yeah, we're gonna write x equals 2 because they want what whole number is equal to f prime of 2. Now, this gives me 16, which is our correct answer. However, say you don't have a calculator with an integral on it, or you're watching this one at the end of the term, because the end of the term, you're gonna start using non-integral calculators, which most of them don't have the integral button. Okay, non-integral calculators, all of them don't have the non-integral button. But I mean, most of them won't have the derivative function. So what whole number is equal to f prime of 2? Okay, what we're gonna do is we're gonna know something called the quotient rule. Say you have a function f of x. Okay, now this f of x is equal to u over v, both of which are in terms of x. In terms of x. Okay, now here the derivative for this is going to be f prime of x is equal to the square of the denominator. That's how I always like to start it. Then the derivative of the numerator, u prime, okay, multiplied by v is the denominator, minus the derivative of the denominator, v prime, multiplied by the numerator, u. Now this is the rule, and I'm gonna keep it up here for a bit. So f prime of x is equal to all over v squared, u prime v minus v prime u. I'm gonna keep this here, okay? So we have this. Now we want the derivative of this function, and then we're gonna substitute 2. Okay, so here in our case, f prime of x is gonna be v squared, so 1 plus x squared. We're not gonna expand this. We're gonna leave it like this. Now, how do we derive? If you remember, y is equal to k times x power of n. So then y prime will equal to n times kx to the power of n minus 1. This is the general rule, right? So basically, you take the exponent down, and then you minus 1 from the exponent. That's how you do derivative. Okay, so now doing it for 18x squared. So y equals 18x squared. Okay, now y prime, we're gonna take the 2 down, the 86. 2 minus 1 is just gonna be 1. We're not gonna write x to the power of 1, we're just gonna write x. So 36x. Okay, now this is the first part. Now we have the v, right? We finished 2 prime, we have v. Now to do v alone is just 1 plus x. We don't need to do anything. Now minus v prime. V prime here, it's 1 plus x. Right? V is equal to 1 plus x. Now v prime, okay, this constant, any constant, provided it's not multiplicative, it's additive, right? So there's the addition, not the multiplication, okay? It's gonna derive to 0, it's gonna differentiate to 0, plus here you see that this is gonna be x to the power of 1, right? We're gonna take the 1 down, 1. Then 1 minus 1 is 0, so this is gonna be 1x to the power of 0, which can be rewritten as 1, right? Because anything to the power of 0 is 1, so it's gonna be 1, right? Now, minus 1 into u is 18x squared, so 18x squared. This is my derivative. Now, because it's a computer multiple choice part, right, I can stop here and substitute 2. I'm not going to simplify this. I can if I wanted to. I would expand this into 1 plus x, and then subtract 36x squared minus 18x squared, and then I'd get the finalized derivative. That's totally fine if you want to do it. But I'm going to stop here because they're not asking me what the derivative function is overall, right? They're only asking me the value of the derivative at 2, right? They're not asking me to type in what the derivative actually is. So I'm going to stop here and write 36 times 2. I'm going to substitute 2 instead of all x, so it's going to be f prime of 2 is equal to 36 times 2 into 1 plus 2 minus 18 2 squared over 1 plus 2 squared, right? Now, 36 times 2 into 1 plus 2 minus 18 2 squared over 1 plus 2 all squared. This gives me 16, which is my correct answer. Okay, question 2. Given f of x equals 20 radical x squared plus 36, what whole number is equal to f prime of 8? Okay, now here you might be thinking we might have to apply the product rule, which if you don't know is when you have f of x is equal to u times v. So then your derivative is going to be f prime of x. Sorry, let me rewrite that needs to be. F prime of x is equal to u prime v plus v prime u. Basically the same thing as the quotient rule. Instead you're changing the minus into a plus and there is no square of the denominator, right? However, again, u and v have both to be in terms of x. They have to be in terms of x. This is important. They have to both have x in them, right? Here, v, let's take this as u and this as v, right? Because it's f of x equals to 20 times radical x squared plus 36. All right, that is fine. Okay, that's this is just a function. We're rewriting what's given. Okay, now we're taking this as our u, this is our v, right? Because it's u times v. U is not in terms of x, right? This is not in terms of x. It's not in terms of x. Okay, however, v is, but again, the condition is both of them have to be in terms of x. If one isn't an x house, you can't apply it, which actually makes our life easier. Why? Because as I said, this is a multiplicative constant, right? It's a constant with a multiplication symbol. That means it's like this. Okay, so we just have to find the derivative of this and multiply it by 20. Okay, because multiplicative constants, they don't get derived. They don't get differentiated. Now, we're going to assume, okay, g of x. We're going to make another function equal radical x squared plus 36. Okay, now for this one here, we're going to apply something called the chain rule. Okay, so we're going to say let u equals to x squared plus 36. Now that means g of x is just going to be radical u. Okay, which is very easy to differentiate. Why? Because it's going to be u to the power of 1 over 2, right? So g prime of x is going to be half u, and then subtract 1 from 1 over 2, so it's going to be minus 1 over 2. Okay, you might think, okay, we stop here. No, we have to derive what's on the inside as well. Okay, we have to derive what's on the inside of u, right? Because remember, we said let u equal x squared plus 36, right? So we have to derive what's on the inside, which is here, which is, we have to derive u itself, and we have to derive outside. Now, so deriving this inside part here, x squared plus 36, right? What do you get? Now, x squared derives to 2x, right? 2x, but 36 derives to 0, differentiates to 0, because it's a constant. A derivative of a constant is 0. So we're going to erase this, and we're going to change this to u prime equals 2x, right? So we're going to multiply this by 2x now. Okay, so now this is our derivative. In general, by the way, let me just say, if you have y equals u to the power of n, again, u is the thing we defined. U can be anything, but it has to be like a function inside of a function, essentially, right? It has to be, for example, x squared plus 36, x to the power of 4 minus 12, x cubed plus x squared, whatever. You can see it's like basically a polynomial, right? The derivative of it, so y prime, okay, I'm leaving this on the side. Y prime is going to be d y by du times du by dx. Okay, so this is the rule. This is essentially what I did, right? I did this here, right? Or in simpler terms, right, I derive what's on the outside. Okay, so I derive what's on the outside, so it's going to be nu to the power of n minus 1 times the derivative of u itself. This is just a simpler form. Okay, this is like an easy way of remembering it. Now, that's essentially what I did here. I'm gonna rewrite u in terms of my original function, right? So what did I say u was? U was x squared plus 36. So it's gonna be half of x squared plus 36 to the power of negative 1 over 2 times 2x. Okay, now I'm gonna erase some things here. Now I'm gonna take it up. I'm gonna go up here. Okay, so Now, this part here means that it's a negative exponent, means it's going to go on the denominator, right? So this can be rewritten as 1 over 2 x squared plus 36 to the power of 1 over 2 times 2x, which simplifies to 2x over 2, right? 2 into radical x squared plus 36, right? Because listen, this 1 over 2 means a radical, right? It's this part is the what it's raised to on the inside, and this is the index, so it's going to be index 2, but you never write the 2 here, you just leave it, right? So that's essentially why we did the radical. This and this will cancel. Okay, it's going to give me x over radical x of x squared plus 86, right? But we're not done, because again we have to multiply it by the 20. So f prime of x, right? So sorry, f prime of x is equal to 20 times x over radical x squared plus 86. Now we're going to substitute 8 into this. So 20 into 8 over radical 8 squared plus 36 gives me 16. So this is going to be 8. So we're going to swap 8 with everything we have here. This equals 16, and that's my final answer. Now, it might have sounded confusing, but I will explain more towards the end. There are many examples of chain rule mixed with product rule, mixed with everything in this quiz. So you will get it later. And just remember, this is the chain rule. This is essentially the chain rule. Please remember it, okay? It's very important, and you will use it later. The official mathematical definition is y prime is equal to du by dx, or sorry, let's say, you can do it in any order you want, but dy by du times du over dx. But you don't have to use this, you can use the shortcut I gave you, which is just derive on the outside whatever is on the outside, okay, when it's a polynomial, of course, right? When you said let u be something, and then derive what's on the inside, okay? That's what, this is just a shortcut to the chain rule that makes our lives generally easier. Anyway, if you want to do this on a calculator, you obviously can as well. So shift integral 20 radical x squared plus 36. Okay, and then we're gonna move over to the x equals box. We're gonna type in 8. This gives me 16 too, and that's the correct answer, of course. Question 3. Given f of x equals to 200 over x to the power 4, what whole number is equal to f to the power, or f prime, or of minus 2, whatever. Okay, now this is very easy. A lot of you might also think we do quotient rule, sorry, but quotient rule, again, u over v, both of these have to be in terms of x. Okay, you can't do them for any random function. No, this has to be something x, and this has to be something x. Okay, it has to have x in it. Okay, now here what we can do instead is we can rewrite f of x as, instead of saying 200 over x to the power of 4, I can take this up, right? So I can say 200 x to the power of negative 4, right? It's the same exact thing, because remember, negative exponent means I take it down to the denominator. But now this makes my life way easier when I want to derive, right? I can write f prime of x is equal to, I can apply the core derivative rule, which is when I have kx, the derivative is going to be kx to the power of n, so it's going to be n times kx to the power of n minus 1, right? So here I have 200x to the power of negative 4. I'm going to take my negative 4 down, so negative 4 times 200x, then subtract 1 from the power, so it's going to be minus 4 minus 1, which is minus 5. Don't say minus 3, don't get confused, it's not minus 3. Okay, now that we know this, so f prime of x can be simplified to, obviously you can leave it like this because they're only asking for the value of the derivative at negative 2. But if they asked you find the derivative, like type in the derivative, you are going to simplify this. So it's very easy to simplify. Negative 4 times 200, negative 800 x to the power of negative 5, which if you want to simplify it even further is just negative 800 over x to the power of 5. Okay, so now I'm going to substitute a negative 2 into this. Right, so I'm going to type in negative 800 over negative 2 to the power of 5 equals 25, and that's my answer. Now, question 4. Given f of x equals x squared plus 2x to the power of 4. What's the value of f prime of 1? Okay, now you can see here, this is a polynomial, right? This is x squared plus 2x. This is x plus x something, right? So this means that we can write this as u, right? We can say this is u, and then we can apply chain rule. So f of x is equal to x squared plus 2x to the power of 4, right? Let me rewrite this too. 2 6 7. This is also so. Okay, now we can say let u equal x squared plus 2x. Okay, now we can erase all of this and just say u to the power of 4. Very simple. Now we apply our chain rule, which is y, when y equals u to the power of n, okay, y prime will equal to n u to the power of n minus 1 times u prime, right? So f prime of x is going to equal to 4u to the power of 3 times what's on the inside of u here. We're going to derive this. So this was 2x, right? Yes. So deriving x squared is going to give me 2x, okay, plus 2x is going to derive to 2. Okay, because remember, it's 2x to the power of 1, we take 1 down, it's going to be 2 times 1, which is 2, then 1 minus 1 is 0, so 2x to the power of 0, right? This is my derivative, okay? Now, I'm going to expand u back, so 4, what's u again? U is x squared plus 2x cubed into 2x plus 2, and I'm going to leave it like this, okay? Now, I'm going to substitute 1 into f prime of x, so 4 into 1 squared, plus 2 times 1, and then all cubed. Remember, you have to write in a bracket. So this is actually going to be something like this. 1 squared plus 2 into 1 cubed, 2 into 1 plus 2. This should look something like this on your calculator. Doing this on your calculator will give you 432, which is our correct answer. Question 5. Is this the question 5? Let me resume the video when it finishes loading. Okay, question 5. So, given that g of x equals u of x plus v of x, and u prime of x is equals to 10 plus 4x minus 3x squared, and v prime of x equals to x squared minus 4x plus 7, what is g prime of x equals to? Now, listen, this is a general rule. It's just the derivative of a sum. Call it the rule of the derivative of the sum. When you have function f of x equals to any two other functions, g of x plus h of x, okay, then the derivative of f of x, let's say f prime of x, is equal to g prime of x plus h prime of x. Okay, this is just a general rule you should know. Now, applying this, so we have f of x is equal to, g of x, so let me erase this. G of x is equal to u of x plus v of x. That means g prime of x is going to equal to u prime of x plus v prime of x. Okay, so this is now very easy, right? Because we have u prime, we have v prime, and we want g prime. So it's very, very, very simple, right? So how do we do this? Okay, so the way we do this is actually very easy. So g prime of x is equal to u prime of x. What is this? So g prime of x is equal to u prime of x plus v prime of x. Now g prime of x is equal to 10. We're copying u prime of x now, so we're copying this here. 10 plus 4x minus 3x squared plus 3x squared minus 4x plus 7. If you don't know where that part came from, it's just v prime of x, which I copied over. Okay, so now simplifying this, we get g prime of x is equal to, so we have, to start, we have our constants. Our constants are 10 and 7, so we're going to add them up, 17. Okay, now we have our x to the power of 1 term, right? So 4x and then minus 4x, these two are just going to cancel out, right? Done. Now, minus 3x squared plus 3x squared, it's going to give me 0, so this cancels out. So this is just g prime of x. That's it, done. G prime of x is 17. That's the full answer. Now, question 6. If y equals 54, over radical x plus 24 radical x. What is dy by dx equal to when x equals 9? This is very easy, okay? It is also the same thing as the derivative of the sum. The y prime is equal to f prime of x plus g prime of x. Okay, this is just something you should know. Now, here, we're gonna have to derive this first. So, 54 over radical x. Now, the way this can be rewritten as 54 over, this is x to the power of 1 over 2, right? So this means that this is 54 into, if we take this up, it's gonna be 54 into x, negative half, right? So, deriving this, so this gives me the derivative to be, negative 0.5 times 54, negative 27, x, so negative half minus 1 is negative 3 over 2. This is my derivative for the first one, right? Now I can also simplify this by just saying negative 27 over radical x cubed. So this equals to negative 27 over x radical x, right? This is the derivative for this, okay? I'm gonna put a box around it. Now, our second function that we're gonna derive is 24 radical x. So 24 radical x is actually even simpler to derive, because listen, if you have, I'm gonna give you this rule to memorize. Just memorize it, and it's very, very easy. It's gonna make your life very easy. So if you have y equals k radical x, okay, then y prime is just gonna be k over 2 radical x. This is just the rule, okay? Obviously, you can find this by deriving, and if you want me to, I will do it right now. Look, so this can be rewritten as 24 into x 1 over 2, okay? Now, so this makes y prime equals to 1 over 2 times 24, 12x to the power of negative half, right? So, essentially, when I take this down, it's going to be 12 over radical x, and that's my answer, right? So here we can see that when we had k equals 24, right? So k was 24. What's 24 over 2? 12. 12, and then the radical x, obviously we simplified, so it's 24 over 2, right? The 2 and the 24 cancels out, so it gives me 12. But we can't cancel out the radical x, so it's just gonna be 12 over radical x, and this is just a rule, okay? Just memorize it. Look, it's a very simple rule that you can easily find if you forget it. But for our purposes, okay, just to make our lives easier, I'm giving it to you, okay? Obviously, show your work in a written point. Don't do this in a written point. Don't say this, okay? Maybe you might get the mark for saying this explicitly, but don't say it, just to be safe. Show your work in a written point. So, 24 radical x, then the derivative is just going to be 24 over 2 radical x. The 24 and the 2 will simplify to give me 12 over radical x. This is my derivative. Okay, now I'm gonna put a box around this. Okay, so I can simplify this now. Y prime, so I'm gonna use a different color. I'll use green. Y prime is equal to 12 radical x plus negative 27, so it's gonna be minus 27. Minus 27 x radical x. Okay, so now they want when the y prime, dy by dx means y prime, which also means f prime of x, same exact thing. When x is equal to 9. So I'm going to substitute 9 in my y prime. So I have 12 over radical 9 minus 27. Okay, sorry, let me just move this up. Radical 9 minus 27 over 9 radical 9 gives me 3, and 3 is my answer. That's correct. Moving on to question 7. Okay, question 7. So we have y equals to 54 radical. Okay, this is the same exact one. I'll unpause the video when it loads. Okay, so question 7. The table below gives the values of functions u and v and their derivatives when x equals 10. If y equals ux and multiplied by v of x, what is the value of dy by dx when x equals 10? Okay, same exact thing. Y equals ux vx. Okay, now what's different about this one though, okay, is that we're not applying y prime equals u prime of x plus v prime of x. No, we're not applying this. Why? Because this isn't addition, right? There is a multiplication in here, right? Because it's u of x multiplied by v of x. So what we're gonna do instead, we're gonna do the product rule. What does the product rule say? You have a function f of x equals u of x v of x. Okay, so now the derivative of this function is gonna be u prime of x multiplied by v of x plus v prime of x multiplied by u of x. Okay, this is our rule. Basically the same exact thing as the quotient rule, except you're changing the minus into a plus, okay, and you're removing the v squared from the denominator. The same thing. You memorize one, you're memorizing the other, essentially. So now, you know, I'm gonna leave this up. Okay, I'm gonna leave this up. So y equals to y prime is gonna equal to u prime of x v of x plus v prime of x u of x. Okay, now okay, so they want u prime, they want y prime, right? So we're gonna have to apply this product rule. Okay, applying it is fairly simple. So we're gonna find u prime of 10 first, right? So they want y prime at 10. So u prime of 10, where is it? U prime when x equals 10. How do I close this? So y is equal to y prime is equal to u prime of x v of x plus v prime of x u of x. Let me erase this part. Okay, now we're gonna find u prime of x when x equals 10, which is this, right? So y prime is equal to 4 multiplied by v of x. V of x when x equals 10 is this, so negative 3, plus v prime of x, so v prime when x equals 10, 2. Now u of x when x equals 3, so when x equals 10, which is this, 16. Right, I'm applying the product rule, except I have all the values basically given to me already. Now, applying this, 4 times negative 3 plus 2 times 16 gives me 20. And 20 is indeed my answer. Question 8. If y equals 7x squared minus 6 to the power of 1 over 4, what is the value of dy by dx at x equals 1? Okay. Here, we're gonna say this is u, right? Because it's a polynomial, okay, and we have x. That's fine. So y is equal to u to the power of 1 over 4, okay? Because as you can see, it's a function inside of another function, right? That's essentially what the chain rule is. This here is a function, right? I can say f of x equals 7x squared minus 6, right? And then 1 over 4, I can write it as a function too. I can write g of x equals to x to the power of 1 over 4, right? So this is a function inside of a function, okay? So now that we know that, that's essentially what the product rule is. That's when you can apply the product rule. So I'm going to leave it up here. Y prime is equal to n times u to the power of n minus 1 times u prime. Okay, this is my shortcut to the product rule. Okay, now obviously I'm gonna say let u equals 7x squared, or 7x power of 12, sorry, 7x power of 12 minus 6. Now, deriving this, okay, it's gonna be 1 over 4 u, what's 1 over 4 minus 1? Negative 3 over 4, I don't need the calculator for this. Times, deriving what's on the inside, it's gonna give me 12 times 7, 84. X to the power of 11, because I'm subtracting from the power here, subtracting from this. Minus 6 will differentiate to a 0 because it's a constant, right? Constants will derive to 0. Derive or differentiate, that's the same thing. Into 0. It's fine. Now, y prime, okay, y prime is equal to 1 over 4 times 7x squared to the power of 12 minus 6 to the power of negative 3 over 4 times 84x to the power 11. Now, if you want to, you can obviously simplify this. But however, again, they're not asking you for what the derivative is. They're not asking you to simplify this and type it on the computer. No, they're only asking you for the value of the derivative at a certain point. So I'm not going to simplify it, because why would I simplify? This is a lot of work to simplify. I'm just going to leave it like this. So I'm going to substitute x equals to 1 into all of them. So 1 over 4 into 7 multiplied by 1 to the power of 12 minus 6, close the bracket. Again, all of this should be bracketed, right? To the power of negative 3 over 4 times 84, 1 to the power of 11. Get out of the exponent, times 84, 1 to the power of 11, gives you 21, and 21 is your answer. So, moving on to question 9. If y equals 1 over 24 into 9 minus 8x to the power of 18 to the power of negative 6, what is the value of dy by dx? Okay, so here, this is actually interesting, right? This is multiplicative constant, so this obviously never gets derived. And then this is our u, okay? Because as you can see, it is to power. It is a polynomial or a function raised to the power of another function, in other words. So y equals 1 over 24, u to the power of negative 6. And again, let u equals 9 minus 8x to the power of 18. Okay, so y prime, okay, it's just going to be 1 over 24, because remember, the constant, the multiplicative constant, whenever I have multiplication and I have a constant, never gets derived. So I take this down, I keep it the same. 1 over 24 times n u to the power of n minus 1 times u prime. Okay, so this is essentially my modified chain rule, because I have a constant. So if you want me to actually modify this rule, it's going to be y prime is equal to k, given that obviously I have y equals k u to the power of n, y prime equals k, so let me write this in another space, y prime equals k times n, k times u, or nu to the power of n minus 1, times u prime. This is my modified chain rule. However, I would avoid using this because it's very easy to like figure it out without this. And again, it's already a push writing this on your written part, right? I don't want you to lose marks on your written part, and this is already a push. So I would avoid this k times nu. I would avoid this in general. I would write the official mathematical way, which is y prime is equal to dy by du times du by dx. You don't have to follow this. You don't have to follow this on your written part, by the way. You can just write this down, just so your teacher knows that you know what the derivative of u is in the chain rule, and then you can follow the shortcut. You can follow this, but you don't write it down. Okay, so anyway, besides the point, I'm not gonna write this. If you want to, you can screenshot it and copy it, and you can also screenshot the other rule I made. I didn't make it, obviously, it's a common rule, but that I wrote. Well, it's your free to do whatever you want. So for all intents and purposes, I'm just gonna use this. So 1 over 24 times, I have u to the power of negative 6. So it's gonna be negative 6 u to the power of negative 7, because negative 6 minus 1 minus 6 minus 1 is minus 7, right? And I took minus 6 down. So times u prime, this constant will derive to a 0, okay? And this is to the power of what, 18? I don't know why that got raised. So 18, so this is going to be minus 8 times 18 minus 144 x to the power of 17. So it's going to be minus 144 x to the power of 17. Okay, now they want this value here. Again, I can't simplify it, but why would I? Because they already just want me to find the derivative at a specific point. So I'm going to substitute x equals 1 into this. Now doing that, I'm going to get 1 over 24 times negative 6. I forgot to expand u here, but you can do it on the calculator already. So negative 6 into 9 minus 8x to the power of 18. So x is equal to 1. So it's going to be 8 times 1 to the power of 18. Actually, let me just show you what I mean on pipe hand. So I'm going to move this up. Y is equal to, y prime is equal to, 1 over 24 times negative 6 into 9 minus 8x to the power of 18 to the power of minus 7 times 144x to the power of 17. Okay, now I'm going to substitute 1 whenever I have x. So here, here, and here. Okay, and always remember the bracket here. This is a bracket. You have to bracket it so that the exponent applies to the whole thing. Okay, so 1 over 24 times negative 6 into 9 minus 8 into, substitute 1 for the x to the power of 18. then close the whole bracket to the power of minus 7 times 144. So I don't know why I put the minus there. Times negative 144, 1 to the power of 17. This gives me 36, and that's my final answer. Question 10. If y equals 6x to the power of 7 minus 5 to the power of 5, what is the value of dy? This is the easiest chain rule question. So this is going to be u, right? So y is equal to u to the power of 5. I'm no longer going to write let u equal blah, 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 right? You can figure it out by yourself by now. I already showed you what u is. So y prime is going to be n u to the power of n minus 1 times u prime. So this is the best demonstration I could possibly show you, right? So first I'm going to derive what's on the outside, right? So this is going to be y equals u to the power of 5. I already wrote that. So I'm going to derive this expression here. I take the 5 down, 5u, then subtract 1 from 5, 4, times u prime. I'm going to derive what's on the inside. So my u is 6x to the power of 7 minus 5. It's this, right? So this negative 5 will differentiate to a 0, right? So I'm going to ignore this. 6x to the power of 7, take the 7 down. 6 times 7, 42. X, 7 minus 1, 6. This is my derivative. Now I'm going to expand u. I'm going to show what u is here. So 5 into 6x to the power of 7 minus 5 times 42x to the power of 6. Okay, now I actually have no space, so I can't write in this area here. That's why I wrote it up there. But it's not traced to an exponent of x 42x to the power of 6. No, it's not what I wrote. I meant to write times 42x to the power of 6, but there is no space. So now 5. So now they wanted that x equals 1, so I'm just going to substitute 1. 5 into, open the bracket, 6 times 1 to the power of 7 minus 5, close my bracket, okay, to the power of 4. The whole thing is raised to the power of 4, right? I forgot to add it almost. To the power of 4 times 42 times 1 to the power of 6. Gives me 210, which is my answer. Question 11. Okay, this is also an example of the chain rule, except with the constant. So, y equals 3, 6x to the power of 5 minus 5 to the power of 4. Okay, so this is going to be u, right? So it's going to be y equals 3u to the power of 4. Okay, so let me get this right. Now, y prime is going to be 3 times 4u cubed, right? Because I'm deriving 4u. Remember, the rule is y prime equals k times n u to the power of n minus 1 times u prime, right? So now I finished these two parts, tick and tick. I have this part left, u prime. U prime is very easy to derive. 5 times 6, 30, x to the power of 4. This will differentiate to a 0, so I'm going to ignore it. Despite the minus 5. Okay, so this is my derivative. Now, substituting for u, it's going to be 3 times 4, 6x to the power of 5 minus 5 times 30x to the power of 4. Right? So now, substituting this on my calculator, 3 times 4 into 6. They want that x equals 1, so 6 into 1 to the power of 5 minus 5. This is cubed times 30 times 1 to the power of 4. This gives me 360, and that's my answer. So as you've seen, the rule does work. Okay, the rule where y prime equals when you have y equals k u as the power of n. Whenever u is a function of x, you can say it is k times, and obviously it's a polynomial, so it's x squared plus 4x, for example. Okay, it's a function inside of a function. Remember, that's when you use the chain rule. That's the simplest way I can memorize it. A function inside of a function. K times n u to the power of n minus 1 times u prime. This is just general rule. Obviously, you can find this by actual derivation, but do whatever way you want. Question 12. Now, this is also an application of the chain rule. So we're going to say this is our u, right? So it's going to be radical u, which can be rewritten as u to the power of half. Now, y prime is gonna be, since there is no k is 1, we're not gonna write it. It's gonna be 1 over 2 radical u. Remember what our rule was? It was when y equals to k radical x, y prime is gonna equal to k radical over 2 radical x, right? K is 1 in our case. So it's gonna be, and u is our x, right? This is u. Same thing, right? Because u, x, you're just changing the letter in our case. So it's gonna be 1 over 2 radical u. That is for n u to the power of n minus 1. Now we're gonna find u prime. U prime is 12x to the power of 11. Now, rewriting this is going to be 1 over 2 radical x to the power of 12 plus 4 times 12x to the power of 11. Now we're going to substitute, or sorry, we don't need to substitute anything. Here, this is where we actually need to simplify, right? So this can be rewritten as 12x to the power of 11 over 2 radical x to the power of 12 plus 4, right? The 12 and the 2 will cancel out. This will give me 1, this will give me 6, 6x to the power of 11 over radical x squared x to the power of 12 plus 4. And that's my answer. Moving on. Fill each blank with a whole number. So, here. This is where we apply quotient rule, okay? We're not applying chain rule here, although it might sound tempting to say this is u and then applying it. It's not in terms of another function, right? So this is our only function, so it's to the power of 1. It's basically its own thing, right? So we can't apply chain rule. We can apply the quotient rule. Remember, the quotient rule is f of x is equal to v squared over u prime v, or sorry, u prime v minus v prime u over v squared. So applying this is going to be y prime. It's going to be give me. So u prime is our denominator. The derivative of our denominator, 10x into v, which is x power 4 plus 1. Minus the derivative of the denominator, which is v prime, which is 4x cubed. Into u, which is 5x squared. All over x to the power of 4 plus 1 squared. Okay, now simplifying this gives me y prime equals to 10x to the power of 5 plus 10x minus 20x to the power of 5 over x to the power x power 4 plus 1 all squared. Okay, I remember I just distributed what I have. So negative 4x cubed into whatever. Okay, that's it. Now, the 10x to the power of 5 and the negative 20x to the power of 5 will cancel out to give me minus 10x to the power of 5. So minus 10x to the power of 5, and then the 10x will stay the same. What? Oh, okay, they did something weird. I don't know why they did that. What they did was, they, as you can see here, they kept the first part, they kept this intact, okay, they didn't expand it. They kept 10x to the power of x to the power of, into x to the power of 4 minus 1, but they expanded this. Right? So what they did is they kept the same thing here, 10x to the power of 10x into x to the power of 4 plus 1, right? Minus, and expanded this. So when they expand this, you get minus 20x to the power of 5 over x to the power of 4 plus 1 all squared. This is weird, right? Because they expanded the second part, right? Like we got the same answer as they did essentially. But what I did, I expanded further. I simplified. Here, they expanded this, okay, they simplified it. This was simplified, but this was kept the same. I don't know why they did that, but I guess it makes your life easier. I just didn't check the answer. So this is the correct answer. Keep in mind, the answer I got was correct, but it's simpler than what they wanted. I've never seen anyone complain about this. Is chain rule. Y equals u to the power of 4, so y prime is 4u cubed times deriving this inside the constant plus 1 will differentiate to a 0. This will be 15x squared. So y prime, okay, is equal to 4 into 5x cubed plus 1 cubed times 15x squared. Okay, so this is the first part of our answer, as you can see, right? Look, 5x power of 5x cubed plus 1 cubed, and then 15x squared. Now, they wrote equals and then they got this. How did they get this? They just simplified what we have. So simplifying this will give me y prime is equal to, now, 15 times 4, 60. 60x squared, and then they kept this the same. They kept the 5x cubed plus 1 cubed the same. Okay, done. This is our correct answer. Okay, moving on, question 15. This is actually a mixture of product rule and chain rule. So, y is equal to 5x into x minus 2 to the power of 9. Okay, now, how would we find this? Okay, the way to find this is not that hard. It just needs a little bit of focusing. So what you do here is, actually, do you need chain rule for this one? I don't think you do. I think you can find it normally, but you can also find it using the chain rule. Okay, so actually, now that I think about it, you do need the chain rule. So this is gonna be 5x times u to the power of 9. Okay, now y prime, since this is a product rule, it's gonna be u prime v plus v prime u. Now that's my formula, right? So this is y. Okay, now this is u, this is v, right? Let me start off by finding what actually, to avoid confusion, I'm gonna express this as f of x, I'm gonna express this as g of x. Then in that case, it's gonna be y prime is equal to f prime of x times g of x plus g prime of x f of x. It's the same exact thing as u and v, right? You can use u and v, but because I already have u here, it's just going to be confusing. I don't want to confuse you, right? You can assume f of x is u and then this is v. This is totally fine, but we already have u up here, right? So it's really, really confusing to work with. Okay, so f of x is equal to 5x. That means f prime of x is equal to just 5. So g of x is equal to u to the power of 9. That means g prime of x is equal to 9 u to the power of 8 times what is u? U is x minus 2. This will differentiate to 1, right? Because the constant will differentiate to 0. And this is x to the power of 1. Take 1 down. 1x to the power of 0 can be rewritten as 1. So it's just this one. Meaning that it is going to be 9 times x minus 2 to the power of 8. Okay, this is essentially what I have to work with. Okay, now I can easily apply the product rule. So 5 into f prime of x into g of x. G of x is u to the power of 9, which is, I'm just going to write it as x minus 2 to the power of 9. Okay, plus g prime of x, 9 into x minus 2 to the power of 8, multiplied by f of x, which is 5x. Okay, so now I can get rid of all of this, so I have more space to work with. Okay, I just applied this. So now I'm gonna keep the first part the same, 5. So I'm gonna write it up here actually. 5 into x minus 2 to the power of 9. Okay, this part here I'm gonna multiply 9 by 5x. Why did it take me so long to say that? 9 by 5x is 45x, so it's gonna be plus 45x into x minus 2 to the power of 8. Okay, so that gives me my first part of the answer, this part here. 5 into x minus 2 to the power of 9, that's correct, plus 45x into x minus 2 to the power of 8, that's correct. However, now they want me to continue. They want me to factor, okay, they want me to factor all of this. So this is y prime, right? This we can't stop here, but however, they want you to keep going. So y prime is actually going to be, let's factor 5x minus 2 to the power of 8, right? Because 5 is a common factor across 5 and 45x, right? What did I open? How do I close this? Oh my god, I have to restart. So y prime is equal to 5x minus 2 to the power of 9 plus 45x to the power into x minus 2 to the power of 8. Okay, this is where we left off, right? Now, I'm gonna factor 5, okay, because it's a common factor across 5 and 45x, right? They're both divisible by 5, and this is the least common multiple. Or the greatest common factor, actually. Now, there you can see they're both x minus 2, right? But which one do I take? I take the one with the least exponent as my factor. Can I stop opening some sort of notes? For the millionth time. 5x minus 2 to the power of 9 plus 45x into x minus 2 to the power of 8. Okay, now y prime is going to give me, this is y prime. Okay, factor 5 out, x minus 2 to the power of 8. Why? Because you always take the one with the least exponent as a common factor, just so it can be divisible by both, right? Now doing this, this is going to leave me with, divide 5 by 5, 1. X minus 2 to the power of 9 and divided by x minus 2 to the power of 8 just leaves me with x minus 2, right? X minus 2 to the power of 1. Plus, right? Because I finished this first part. This first part is factored out. Done. Now it leaves me with this part. 45 divided by 5. 45x divided by 5. 9x. Right? Now, x minus 2 to the power of 8 divided by x minus 2 to the power of 8. Nothing. Right? Cancels out. So this is my actual factor. Now, I can simplify this, right? So 5x minus 2 to the power of 8 into x minus 2 plus 9x. Right? So I'm going to erase this part here. X minus 2 plus 9x. I just left the bracket open now. Because remember, there was a bracket here. I took it off. Now, 9x plus x, 10x. Minus 2. And obviously, this gets copied over. So, 5 into x minus 2 to the power of 8. Done. Got it here. Now, into 10x minus 2. Done. Got it here. So, moving on to question 16. How much long is this quiz? I believe it's 16 and 17, right? Yes, just 16 and 17. Okay. Didn't I just do this? Yes, I did. Okay, now, what? Okay, there we go. This is the actual question. Now, here you use quotient rule. So, y prime is equal to 6 minus x all squared into the derivative of this is going to be 2x minus 8. So 2x minus 8. Okay, open the bracket here. Into 6 minus x minus 6 minus x, the derivative of it is just going to be minus 1. Minus 1 into x squared minus 8x. Okay, so now, how do we do this? Okay, it's very easy. So, we're just gonna expand. Sorry, this copybook came out from my. So, expanding this will give me y prime 2x to the power 2x times 6. It's gonna give me 12x, right? 2x times negative x minus x 2x squared. So minus 2x squared. Okay, now negative 8 times 6 minus 48. Negative 8 times negative x plus 8x. Okay. Minus and minus make plus. So this is actually plus 1 into x squared minus 8x. Right? The minus and minus, I combine them to make a plus. Right? And then I just rewrote it for anyone who's confused. Okay. So this is going to give me plus x squared. I'm expanding plus 1 into this. So it's just going to stay the exact same thing. Minus 8x. And this is all over 6 minus x squared. This looks very confusing because I don't have enough space to write it. But now I can simplify the whole thing. Right? Simplifying. Y prime is equal to 12x plus 8x minus 8x. The plus 8x and minus 8x cancel out. So just give me 12x. Right? Now, minus 2x squared plus x squared minus x squared. And then minus 48 has nothing to go with. So it just stays the same over 6 minus x squared. That's my answer. Done. Okay, obviously they wrote it in a different way, but if you want me to rearrange the way they did, just take this here and then take that there. Same exact way. Done. Okay, part B is chain rule actually. So it's very easy. Y is equal to radical 1 plus 2x squared, close the radical, to 9. So this can be rewritten as, right? This will be rewritten as, let me write it up. Y is equal to 1 plus 2x squared. Actually, let me open a bigger bracket. the power of 9, all to the power of 1 over 2, right? Because this whole thing's under the radical. Now, this means, remember, when I distribute a power to a power, when it's raised to something else, right? These two powers multiply. So y is equal to 1 plus 2x squared into 9 times 1 over 2. Now, do 9 times 1 over 2 on a calculator. Or if you want, it's just going to be 9 over 2, right? Because it won't do anything. This is my... That's not a 4, that's a 9. This is my this is the same thing as y, but essentially just simplified. So y is going to be u to the power of 9 over 2. That means y prime is 9 over 2 u to the power of 7 over 2, because 9 over 2 minus 1 is 7 over 2, times u prime. U prime is going to be, since u is 1 plus 2x squared, right? This is u. Deriving it, u prime is equal to, the constant differentiates to a 0, okay? Then 2x squared, 4x. Times 4x. Now, expanding y prime again, it is going to be, simplifying this, actually, let me simplify it. 4 and 2 will cancel out. This is 1, this is 2. So it's going to give me 18x u to the power of 7 over 2. Now, this is now very, very, very easy to do, right? You should be able to do this. So, taking this up here all the way, y prime is equal to 18x times 1 plus 2x squared to the power of 7 over 2. That means it's going to be y prime is equal to 18x radical, because remember, this is my index, so it's index 2, but I don't write it. 1 plus 2x squared to the power of 7. So y prime is equal to 18x to the power, okay. Now, this is the power of 7, and this is 2, right? So let me rewrite this. It's going to give me 1 plus 2x squared to the power of 6 times 1 plus 2x squared. Obviously, this is all under the radical. Now, this I can take out, right? Because this is 2 and this is 6. So it's going to give me y prime is equal to 18x squared. Okay. Or sorry, 18x. And why have I been writing x squared? No, this isn't x squared. What is this? Samsung Internet? I don't want Samsung Internet. When did I ever do this? So, it's going to be 18x. Right? Radical, where was I? Yes, I remember where I was. So, radical. 1 plus 2x squared to the power of 6 times 1 plus 2x squared. Right? Now, this is 2, this is 6. So when I take it out, it's going to give me 18x into 1 plus 2x squared, 6 over 3, right? Or 6 over 2. Because I'm taking this out. So essentially, I'm raising it to an exponent of 6, because it's already raised to an exponent of 6, and dividing that exponent by 2, because the index is 2. Remember, when you have n to the power of a over b, a is my exponent of whatever it is, b is the index of the radical. Okay, now this is going to be into radical 1 plus 2x squared. Right, this stays the same. I'm not going to do anything to it. Right, now 6 over 2 can be rewritten as 3. And this is essentially the answer. Done. You're done here. This is your answer. 18x into 1 plus 2x squared cubed, radical 1 plus 2x squared. Right? Because look, if you're still confused on how I got this cube, I took this out. And when you take it out, the exponent inside is going to be divided by the index of the radical. Right? So 6 divided by 2 is 3. So 18x into 1 plus 2x squared cubed. Okay? But however, I didn't take this part out with it. This part stayed in the radical. So I'm going to write the radical 1 plus 2x squared to the power of 1. That's it. Done. That's the answer. Question 17. Question 17 is the repeated question from last week, and it's the very, very, very long one, but I'll still explain it, because why not? Okay. So, y is equal to all of this. Okay? So, y prime, very quickly, this is u, right? So, it's u to the power of 4, so it's going to be 4u cubed times the derivative of u is just 5, because it's 5x plus 1. This will differentiate to 0. 5x will differentiate to 5. plus, since again it is addition, so the additive, like, you know, the sum rule, y prime is equal to a prime b plus b prime, right? If y is equal to a plus b, right? This is the rule that I explained before in terms of f of x and g of x and whatever I said. 3 times 2 6, 6x. Now 9x, sorry, minus 9x differentiates to just 9. Okay, now, so this is going to give me y prime is equal to 20, 5x plus 1, since u was 5x plus 1 cubed, plus 6x minus 9. Done. Okay, part B, same thing, but literally even easier. So, this is going to give me y prime as 20x to the power of 4 minus 16x. Now, this part, I'm going to take it alone here. That's its own thing. 6 into x to the power of negative half, right? Because it was initially 6 over x to the power of 1 over 2, right? Then I just took it up. So it's going to give me x to the power of negative half. Remember, radical x means x to the power of 1 over 2. But when it's at the bottom and you take it to the top, the exponent becomes negative. Deriving this, it's going to give me negative 3, because it's going to give me, actually, let me do it slower. 6 times negative 1 over 2 times x to the power of negative 3 over 2, right? Because it's gonna be 1 minus, or sorry, 3 or 1 over 2, negative 1 over 2 minus 1, which is negative 3 over 2. I don't like the Samsung interface when it does this. Okay, anyway, so 6 over radical x, again, as I said, it is gonna be 3 x to the power of negative 3 over 2, which equals to 3 over radical of x cubed, which is x squared times x, right? This is radical x squared times x. I can take x squared out, which is going to be 2 over 2, which is going to be 1. So x radical x. I'm going very, very quickly. If you want a more detailed explanation, watch last week's video explained by Hala. So y prime is 20x to the power of 4 minus 16x minus 3x radical x. And that's the answer. See, if y is equal to 3x squared plus 1 into radical 3x squared minus 1, then blah, blah, blah. Okay, so this is product rule, right? However, one is going to be the U chain rule and the other one is going to be Norman, right? Because this is just a function of itself. And this one, and then the second part, the one under the radical, is a function inside of a function, right? Because the radical in and of itself is a function. And this 3x squared minus 1 is also another function inside of another function, chain rule, right? This is just on itself. 3x plus 1, it's by itself. So this is going to be f of x. Because I'm using chain rule, I'm going to use, and it's like mixed with product rule, I'm just going to use f of x and g of x. This is f of x, this is going to be g of x. Okay, now f of x is equal to, what was it, 3x squared plus 1. Then f prime of x is equal to 6x. Okay, done, that's it. G of x is radical 3x squared minus 1. That means this is my u, so it's going to be radical u. Right, and now you know that the derivative of this is just going to be 1 over 2 radical u, okay, times the derivative of u, which is 6x. Okay, now I'm not going to explain why it's 3x squared minus 1 differentiates to 6x. Actually, I would, why not? 2, you take it down, it's going to be 6. Then you subtract 2 minus 1 is 1, but you don't write it, so done. Okay, now g prime of x is equal to 1 over 2 radical. Sorry, I don't have space. So I'm going to take this all up here. G prime of x is equal to 1 over 2 radical 3x squared. Let me remove this arrow. 3x squared minus 1 times 6x. So it's going to be 6x over 2 radical blah, blah, blah. It's going to give me 3. This and this will cancel. Give me x over radical 3x over radical 3x squared minus 1. Okay, so now that I have these two, okay, so this is g prime of x. So I'm going to erase all of this. Okay, now I can apply my product rule. So f prime of x is 6x into g of x, which is radical 3x squared minus 1, right? Plus g prime of x, which is 3x into radical 3x squared minus 1, multiplied by f of x, which is 3x squared plus 1. Right? So now 6x radical 3x squared minus 1 plus 3x into 3x squared 9x cubed plus 1 over radical 3x squared minus 1. Okay, now this is, we're almost there, we're almost done. It just needs a little bit of simplification. Okay, so now here I'm gonna need to have this as my common denominator, right? Because I need this here so I can simplify this. Now that means I'm gonna have to multiply up and down. So this is 3x squared minus 1, multiplying it up and down. So I'm multiplying up and down by radical 3x squared minus 1, right? So I can get this as my denominator. Okay, so this equals this and this are the same thing, right? So this is going to be 3x squared minus 1 squared, which means the radical will cancel 6x into 3x squared minus 1 over radical 3x squared minus 1. Now, this part, I'm going to put it back, right? So plus 9x cubed plus, what was this? 9x cubed plus 1 over radical 3x squared minus 1. Okay, now expanding this, it's gonna give me 18x cubed minus 6x plus 9x cubed plus 1 all over radical 3x squared minus 1, which simplifies into 18 plus 9, 27 x cubed. This was not what was this? This was not plus 1. This was plus 3x, no? This was plus 3x. So anyway, minus 6x plus 3x is going to give me minus 3x over radical 3x squared minus 1. And that is my final answer. This is my final answer here. Done. Okay. The reason I'm rushing is because this was covered last week. If you want, again, a more detailed explanation, I'm sure Hala explained it really, really well. It's question 10 in last week's quiz. But this is just as like a refresher. This is just to test yourself more than anything. So here, now, this is going to be quotient rule. So, also chain rule. This is f of x. This is g of x. I'm going to start from the top now. F of x is equal to x power of 6. So that means f prime of x is equal to 6x to the power of 5. So g of x is equal to, straight away, I'm going to say u is equal to x to the power of 6 minus 1. This is u, right? It's going to give me u to the power of 1 over 2. Okay, because it's radical u. So this is 1 over 2 radical, what was u? It's x to the power of 6 minus 1. I'm saying it straight away. Plus into multiplied into 6x to the power of 5. I'm deriving really quickly. Because remember, this constant will differentiate into 0 and x to the power of 6 takes 6 down, 6x, subtract 1 to the power of 5. Okay, so that means g prime of x is equal to 3x to the power of 5, because the 2 and the 6 cancel, 3 here, over x to the power of 6 minus 1 under the radical. Okay, now that I have this, I can do the quotient rule. So y prime equals 2, obviously over squared, so x to the power of 6 minus 1. I squared this part here, I squared it. When you square the radical, it cancels out, so x to the power of 6 minus 1. Okay, now it's f prime of x times g of x minus g prime of x times f of x. So f prime of x is 6x to the power of 5 times g of x, which is radical x to the power of 6 minus 1, okay, minus g prime of x. G prime of x is this, so 3x to the power of 5 over radical x to the power of 6 minus 1. Okay, this is over this. Multiplied by, let me just erase this now that I have it. Why do you go to the settings? Multiplied by f of x, which is x to the power of 6. Okay, now that I don't need all of this, since I wrote down my rule, right, y prime is equal to 6x to the power of 5 into radical x to the power of 6 minus 1 minus 3x to the power of 11 over radical x to the power of 6 minus 1. Now, I have to multiply, this is over 1, right? And then obviously I'm not forgetting x to the power of 6 minus 1. But I'm not going to write it down because it's going to take up too much space. I'll write it down in the end. I need this to be common denominators. What will make 1 go to radical x to the power of 6 minus 1? I'm going to multiply up and down by radical x to the power of 6 minus 1. So y prime is equal to 6x to the power of 5 into x to the power of 6 minus 1 times x to the power of 6 minus 1 all under the radical. We'll just square the radical, cancels out, into x to the power of 6 minus 1 over, I'm going to erase you now, radical x to the power of 6 minus 1 minus, since they're the common denominator, I can write them all up by 1 now, 3x to the power of 11. Okay, y prime is equal to 6x to the power of 11 minus 6x to the power of 5 minus 3x to the power of 11 all over, what was it? Actually, now that I think about it, look, these two are common, right? As you can see, I combine them into one fraction, means they have a common denominator. If it's a denominator over a denominator, it means I can take the denominator down into the other side of the fraction. So it's actually going to be x to the power of 6 minus 1 into radical x to the power of 6 minus 1. Right? I just took it down. Remember, because I had this over x to the power of 6 minus 1. So this will simplify. 6 minus 3, 3. So this is my final answer. Done. Okay, that was the end of the quiz, guys. Good luck. Enjoy the rest of your